Okay, so this is just a good question about converting things from general form into Cartesian form. So we're going to start with an object that has a position function like this, and it is stated to be elliptical. Now, that's important because it gives us the general form of an ellipse over here. So we know we're going to be using parametric equations to convert this into terms of x and y, and it should look like something like that eventually. All right, so let's get started. Okay, so the first thing we're going to do is we are going to assign our parametric equations to this part over here. So this is going to become my x component and this is going to become my y component. Now you should notice straight away that these are going to be in different terms because that's t and then that's 2t. So the first thing that I'm going to do is I'm going to use some of our identities to change it so that they are in terms of the same. So if you go to your formula booklet and look at the double angle identities, you'll see that there's one that looks like this. Sine 2a is equal to 2 sine a cos a. Okay, so all I'm going to have to do to this one to change it so that it's in terms of t only is just what it does over here. I'm just going to change it from being like this to like this. So this can also be expressed as y equals 2 sine t cos t. Okay, so now I've got my variables assigned in terms that are going to work out nicely for me. Next thing that I need to do is think about what's happening up here. So I can see that that needs to be squared and that's going to be squared, meaning that I want my x's and my y's to be in terms of squared as well. So we're going to square both of them. So x squared is equal to cos to the power of 4t. Because remember, if I think about that, that's like x squared there. And so if I square that, then it'll become x to the power of 4. And so that's why that one gets the power of 4. Now, when I square this one, y squared, it's going to square each term inside of the bracket. So this will be squared, and this will be squared. 2 squared is 4 sine squared t cos squared t. Okay, so now we've got that looking pretty nice. Next thing that we're going to do is we're going to start adjusting them so that it looks like how we want it to look. So first thing I'm going to do is I don't want to work with the 4 here. That's not going to be nice for us later. So what I am going to do is I'm going to change that into being 2 lots of the squared. Now, as you can see, these two statements are equivalent, so that's all okay to do. For this next one over here, I'm going to start thinking about how I can get these things to all be in terms of x's. So now I can say y squared is equal to 4 sine squared t. And this cos squared part here, you'll notice is the same as this. So I can replace that with x. Now the other problem that I've got here is this one's not in terms of cos. So that one's not looking good at the moment. So what I want to do is I want to convert that using our... What are we going to use here? We're going to use the double angle identities. So, no, sorry, not double angle identities. Pythagorean identities. So generally our Pythagorean identity is sine squared t plus cos squared t is equal to 1. So all I'm going to do is rearrange it so it's in terms of sine squared t is equal to blah. So sine squared t is equal to 1 minus cos squared t. Okay, so that is now going to replace this section here inside my bracket. So y squared is equal to 4 bracket 1 minus cos squared t x. Okay, so next thing that I'm going to do is I'm going to expand out my brackets and I'm going to replace this with what I know. The whole goal of this is to get everything in terms of x's and y's. So I can see that that is equivalent to that, meaning that that can also be an x. So y squared is equal to 4(1) minus x bracket x. Now I can expand my brackets out. 4 minus, so this times this times that, 4x. That's all in brackets, still with the x on the outside. So y squared is equal to 4x minus 4x squared. Okay, so scroll down a little bit so we can see things a bit more clearly. Okay, so the next thing that I'm going to do, because I'm trying to get it back into that general equation, I know that I want to have a 1 in front of the x. So I'm going to factorize the 4 out to try and get it back into that form that we saw in the formula above. So really, at this step here, I could have just expanded this x in and left the 4 out. But, you know, you do what you do. All right, so now it looks like this. I'm going to move this 4 to the other side. Y squared over 4 is equal to x minus x squared. Now, if we just go back up again, I can explain why I've done that. It's perfectly valid for this y to be over a number that's squared. So when I'm trying to convert these things, it's fine to have it underneath, but the term in front of y and the term in front of x both need to be equal to 1. Okay, so let's continue. Now that it looks like, so the next problem that you're going to see is that we currently don't have a 1 in front of the x, but what I could do is I could factorize it out so that I do have just a plain old 1 in front of it. So if I take out the negative 1, I'm left with x plus, negative x plus x squared. Okay, so if I rewrite that nicely and I take this to the other side, I can say that now I've got y squared over negative 4 is equal to x squared minus x. Okay, so now I can try and get it into the form that we've got on the numerator of our fractions in the given equation by completing the square on this one. So to complete the square, all I need to do is think about, now I think about it in terms of this little box, stops me from forgetting things. But, you know, you can choose to do it a different way, up to you. So x times x will get that. I halve this number. So half of 1, or half of negative 1 is going to be negative a half. Okay, and so that is what's going to go into these brackets, x minus a half squared. Now I have to work out what portion is added on to this so that I can take it away to make sure that the equation's all even. So this would become x squared. This would become minus a half of x. This is minus a half of x, and this is going to be positive a quarter, which means to make this expression the same as this, I need to subtract a quarter. Okay, so now this is starting to look a little nicer. Okay, next thing I'm going to do is I am going to move this one across so that I've got my x's and my y's on the same section. Okay, just like it is in the formula, you've got your terms with the x's plus the terms with the y's is equal to, and it should be equal to 1. So y squared over negative 4. I'm taking this away from that side, so minus x minus a half squared over, that's not over anything, is equal to negative a quarter. Now, I want this to be equal to 1. So in order to do that, I'm going to need to multiply this one by negative 4, which means I'm going to multiply this expression by negative 4 and this expression by negative 4. That will make everything work out nicely. So when I times this by negative 4, it's just going to work out to be y squared. When I multiply this one by negative 4, it's going to work out to be positive x minus positive 4 x squared like that is equal to 1. Now, we're really close to getting to what we wanted. You can see up here, I've got the 1 there, and then on this side part here, for the y term, k would be equal to 0, b would be equal to 1, but I haven't quite finished here. Okay, I can see that the h is going to be equal to a half, but we need it to look the same as this, which means that we want to get that a to look the same as that. Now, what I needed to do in order to get that 4 to go to the top there, okay, remember if I have a number like that, I've got a and I divide it by a quarter, that means generally that this 4 will come up and actually multiply. So if I've got the 4 in front here, that is the same as stating this. Okay, and now I've put it into the same display that they've got up here. Now we're just going to read through the question again to make sure that we answered all of the parts. So evaluate the reasonableness of this statement. That's the general Cartesian form, is stated to be elliptical. So all I need to do now is write my conclusion. So therefore, this is elliptical as formulas match. Now, it is important to note as well, if this wasn't a minus in there, that's okay, but this needs to be the same thing as it is above, otherwise they are different equations. So be careful of that when you're looking through these questions. So that plus that's right here, very important. The one that's over here, very important.